This is the first tutorial in a series called CAD for Physicians, in which I'll teach computer-aided design with Fusion 360 using examples and projects that would be of interest to physicians. Each new lesson will build on a previous one. If you need to get a free license to use Fusion 360, go to this website, download a free trial for 1 month, and then follow these step-by-step instructions to convert your free trial to a free subscription as an enthusiast. If you are completely new to CAD or to Fusion 360, I invite you to first watch the first 2 videos in my series called Fusion 360 Simplified that I've made for the general population. In this lesson, we will design pedicle screws, which are used in spine surgery to attach adjacent vertebrae to rods. In the process, we will learn a lot about CAD with Fusion 360. Specifically, our screw will have a dual core design, which means that the upper part of the core will be cylindrical, the lower part will be conical, and it'll have a dual thread design so that the pitch in the upper part of the screw is different from the pitch in the lower part. So let's get started. As always, we start with a sketch. Grab the line tool, select a coronal plane, start on the origin, draw a vertical line to 50 millimeters. Continue it to the right for about 6 millimeters. It doesn't have to be exact. Then draw another vertical line. Make sure it's a vertical halfway down. It doesn't have to be exact. Then draw an angled line all the way to your x-axis. Make sure it's on the line. The angle doesn't have to be exact. And finally, connect to your origin. Press escape. Make sure that your bottom line is actually horizontal. You can go to your constraints and grab a horizontal constraint, which is found here, and click on that line. It'll make it horizontal. Stop sketch. Let's revolve this profile. Go to your revolve command. The profile to be selected is this one. The axis is this line right over here. Press OK. And this is the general design of the core of our screw. Now, of course, we want to assign specific values for the sizes and apply threads to the screw. And we're going to do this parametrically. Let's explain what that means. Go to the Modify menu, grab Sigma or Change Parameters item, and open this screen. And let's define some parameters. Press on the plus sign. The first parameter will be the length of our screw. So we call it capital L. And as an initial value, we'll put in 50 millimeters. Press OK. The second parameter, press on the plus sign, will be the diameter of our screw, the outer diameter, OD, and as an initial value we'll put 6 millimeters. Press OK. The third value will be the depth of the thread, which is from the surface of the core to the tip of the thread, and that's 0.75 millimeters. So we'll say plus TD for thread depth, and the initial value is 0.75. The fourth parameter will be our thread pitch, and that's the distance between the crests of the thread. Notice that we have two different pitches. In the upper part of the screw we have 2 millimeters, in the lower part we have 2.5. So say plus pitch upper, PU, will be 2 millimeters, plus again pitch lower will be 2.5 millimeters. And the purpose of this design and the different pitch is to increase the pull-out strength of this pedicle screw from the bone. So now we have defined all of our parameters. Everything else in this design will be based on these parameters, so that later on, if we want to make a screw of a different size, different length, different diameter, different pitch, we can just come in and change these numbers and it will automatically produce a different screw for us. Press OK. Now let's go back to our sketch, go to the timeline and double click on the sketch. So let's go over each of these lines and redefine them in terms of our parameters. To do that, go to the sketch menu and grab the dimension tool, sketch dimension. You can also use the keyboard shortcut D and click on this length, pull it out, click again. It says 50 millimeters. We want it to be a parameter, and we have defined capital L as the length of our screw. Press return, return again. So now that's defined as a function. Let's do the same thing with this length. Click on it, pull it up, click again, and this is the core radius. The core radius is related to our user-defined outer diameter by this formula. OD, which is outer diameter, divided by 2. That gives us the outer radius. That includes the thread depth, so we will subtract TD from that. Press return, return. Next, we will define the length of the upper core, which is basically half of the length of our thread. So click on this line, draw it out, click again, and we will make that capital L divided by 2. Return. And before we go to the next step, let's reposition this line. Press escape, zoom in, find this point, and drag it over to the other side. And then press the keyboard D, which gives us our dimension tool. And finally, we're going to define this length, which is our lower core radius, and that's going to be half of our upper radius. So let's click on here, and I'll just click on this dimension. It'll enter that dimension as a parameter in here, and then we'll divide that by 2. Press return, return. Stop sketch. Now if we go back to the Sigma menu, we will see that it has defined a whole bunch of new parameters based on our user parameters. And if I were to change my driving parameters to different numbers, let's say a length of 80, it will automatically change my shape. Now let's go over these newly defined parameters and make sure we understand them. D7 was simply the length of our screw, and that's equal to L. D8 was the core radius without the thread. So let's just put that down, core radius. And it was our larger of the two core radii. L divided by 2 is the length of each of the cores. This is a dual core design, so core length for each segment. And D10 was our core radius at the tip. We call it smaller. Very good. So I'm going to screenshot this and keep it around so I can refer to it in the next steps. So now we're ready to apply some threads to our core. Fusion has a command for threads, but those threads are only applied to cylindrical surfaces and cannot be applied to conical surfaces. Furthermore, because they are industry standard threads, you have very little control over the thread profile and the pitch, etc. So we're going to use the coil command to form our threads. Press on the horizontal plane, place the center of the coil on the origin, draw an arbitrary circle out, and then extend the coil up a little bit. And now we're going to look at all these parameters. The type, we're going to control the height and the pitch of our thread, so select that. The diameter we will skip for now. The height of our thread will be basically half of the length of our screw, so it's L divided by 2. Also the same as D9. So I'm going to put D9 in there. Same thing. The pitch in this part of the screw is 2.5. The angle we'll skip for now. The section will be triangular, external, and it'll be applied to the outside surface. And the section size is really the same as thread depth. It'll be 0.75. Go back to the diameter. They're asking about this lower core diameter. Well, let's look over here. Our smaller core radius was D10, so the smaller core diameter will be D10 times 2. Alright, we're going to make sure that this is not cutting but actually joining our thread. The last thing we have to do is specify a thread angle. Let's just put in a random angle of 10 and see what happens. You can see that this angle is too wide and it's not applying the thread to the surface of our core. The appropriate angle is actually the arc tangent of D10 over D9, and I ask you to prove that to yourself. And now you see we have a perfect thread applied to the core of our screw. And we have the join operation. Press OK. Now we're going to do the same thing with the upper part. It'll be a lot easier because we don't have much of we don't have any angle to deal with. The only thing is that we have to start it at this point over here. So first we need to define a new plane, an offset plane. We select, let's reveal our origin. We select the horizontal plane and pull it up. It has to be pulled up to the length of exactly half of our screw. So we can specify that distance parametrically. It is L divided by 2 and press OK. Now we can build our coil. Grab the coil command. We'll press on this plane. Go to the top view. Place the center of the coil on the origin. Go out a random distance. Again, the height and pitch are being controlled. Here the diameter is our upper core diameter, which is twice the core radius. So it's D8 times 2. And our height is L divided by 2. Our pitch in this upper part is 2 millimeters. Our angle is 0 degrees. Our thread is triangular, it's on the outside, and the section size is 0.75. And it is joining our previous body. We have a perfect thread now. Place OK. If we go back up to the Sigma menu, change parameters, we can simply change our length to, let's say, 60, or our diameter to, let's say, 7. And we can create all kinds of screws of different length and diameter while maintaining our pitch profile constant. In the next lesson, we'll learn how to create a screw head.